All right, everyone, welcome to the third installment of the SRIL Planetary Exploration Challenge workshop. Just a quick reminder that next week is going to be the challenge, so don't forget to tune in. And in regarding such, tonight is actually the due date for you guys to submit your codes. We're going to put that into Robot, see if it works, make sure it works, and we'll be ready for next week's challenge. All right, without further ado, let us begin. All right, Daniel, next slide, please. All right, we would like to begin by acknowledging that this workshop is broadcasted from Surrey, British Columbia, Canada, located on the traditional and unceded territories of the Coast Salish peoples. Next slide, please. All right, let's talk a bit about SRIL, who we are. So SRIL is a nonprofit organization dedicated to empowering youth innovators through robotics and STEM. We also acknowledge that there is also an art side to technology. So we're also trying to promote the idea of STEAM, which is a concept that a lot of the STEM organizations are moving forward, standing for science, technology, engineering, art, and mathematics. Without further ado, let's jump into the workshop, and I shall hand it over to our presenter today, Daniel.
Thank you, Clay. All right then, so welcome to our third and final workshop before our final event. So in this workshop, we're going to be exploring programming, whereas last workshop we explored the basics of programming with block coding and how most of you may have started your programming journey. Today, we're going to look at more traditional methods of programming, which have been around for decades, and that is text-based programming. So in this workshop, we will explore the Python programming language, different types of data types and functions, and we're going to look at one programming example in Python where we create a simple calculator. And lastly, we're going to look at how your block code may translate into text code in VEX code. All right, moving on. First, let's start with the big question for this workshop. What is a programming language? So let's see, can I turn on annotation? Yes. All right, so you guys are used to this routine. I turned on annotation. If you could write down, what do you think a programming language is? Let's see what everyone thinks. Anyone have any ideas? What is a programming language? What is it used for? Stuff you write into a computer to make the computer actually a computer. Yes. Stuff you write to the computer, right? So it can actually compute, right? You know, computers are meant to run programs. That's how they're useful, right? So that's correct. I see Clay wrote 011000001. I'm not sure if that's supposed to mean something, but
it's just the
looks
letter
like
A. It's just the letter A.
Ah, the letter A in binary.
Once again, I tried to type on my iPad, but I tried to communicate with computers, but I don't think it stuck the whole word computers.
Yeah, exactly. Communicating with computers. And what's down here? Understand by computer and person. Language for for instruction for computer to follow. Yeah, exactly. Instructions for the computer to follow. That's exactly right. Okie doke. So if there are no further suggestions, let's move on then. All right, I'm going to clear your lovely annotations. And to the next slide. Right, so let's answer the question together. What is a programming language? Well, a programming language is a human readable system for giving instructions to a computer. And in this workshop, as you may have seen, we are going to focus on the Python programming language. And if we look at Python, it uses words and symbols to make it easy to understand. And that's basically common with most programming languages, right? When you think of a programming language, you will think of, there'll be keywords, right? Keywords maybe is like print or string or input or something like that. And there'll be symbols like parentheses that you put in. Basically, it's human readable, right? You can look at your code and say, this is what it does. It does this or it does that, right? Okay, so once you've written your source code in Python, that's the code that you write with the letters and numbers and symbols. An interpreter reads it and converts it into machine code, which your microprocessor can then understand. And we're going to go deeper into this in the next few slides. But your source code isn't exactly the kind of code that your computer can understand right away, because once again, your programming language source code is something that you can read. That's human readable, not exactly computer readable. Okay, so let's go to the next slide. And let's look at the first level, the highest level. So in programming, we say there's like high level programming, there's low level programming. Okay, so what high level programming means is something that is easy for you to understand, but not exactly explicit or specific to the processor that you're trying to program. Okay, so what does it say here? Source code is a high-level way of writing programs. It lets the programmer focus more on functionality and lets the compiler or interpreter handle lower-level tasks such as memory allocation. So let's look at the picture on the side here, right? I think I'm pretty confident that when you think of code or when you think of programming, this is what you think of, right? You think of this programming environment, and like keywords are highlighted in different colors, like this while here, this print here. You know, you have if statements, else if statements. So when you think of code, this is probably what you think of. And if you have written text code, this is it probably looks like what you've written, right? So yeah, so this is high level code. It's code that humans can read easily and write easily. All right, next slide. We move into the lower level regions. So at a lower level, you have assembly language. And assembly is a low level language used to directly access the capabilities of a system. And it allows the programmer to access memory locations directly and processor capabilities directly. So what do I mean accessing it directly? Well, when you, for example, want to print a hello world, for example, on the screen, there's a lot of stuff that goes behind the scenes. Like the processor needs to allocate a space in your memory, in the computer's memory, just like a place in the memory to hold that information, and then it needs to send that information to the output console or your monitor, right? So assembly language lets you control the more minute aspects of that. So if we look at this picture here, it looks more like gibberish, but it's not exactly gibberish because you can still make out some keywords, right? You can make out section, global, you have move, you have message, right? So for example, here, you have message and your message is hello world, but you needed to initialize all of these other things beforehand to call the kernel and to declare a message length, right? And where to put it in the memory, right? So this is assembly language, and a lot of programmers work with this level of programming on a day-to-day basis, but it's not as widespread or as common as a higher level source code programming, right? All right, next slide. We have the lowest level that we're going to look at today, which is machine language. So machine code contains the lowest level data that your processor computes. And not all machine code is the same because each processor family has its own instruction set. But if you think of the modern PCs that we use today, these processors, think of your, Intel processors, your AMD processors in your computers, in your laptops. They use what's called the x86 instruction set, which was first developed by Intel, and then eventually it gained traction and it became popular in PC use. So now everyone in the personal computing space uses x86 as its instruction set. And
except Apple.
Or yeah,
Now
except
they're using their
Apple.
new
Yeah,
M1.
except Apple. They have their proprietary processors. Yeah, so on the picture here we have an example of machine language. And well, would you look at that? It's just a bunch of numbers, right? These numbers actually are a binary number system. So each of this, so this is a number, this is a number, this is a number. It's just represented in binary. And really at the lowest level, that's what a processor looks at. That's what a processor can read. It just reads number. When it reads this, it does one thing. When it reads this, it does another thing. When it reads this number, it does another thing. And when you do all of these things in succession, you will be able to do what you actually want it to do, which is z equals x plus y. So whereas in source code, you would type z equals x plus y, when you compile it into machine code and the processor actually executes it, this is what the processor does. It like opens a gate, or like it closes another gate or something like that. So really that's what machine code is, and it's not very human readable, as you can see, right? I don't know what each of these numbers does. I could probably look it up and figure it out, but just by looking at it, I don't think anyone will be able to figure out what the processor is doing, right? All right, next. Let's look a little bit more, Let's look a little bit more at Python. So Python is designed with an emphasis on code readability by using indentation and white space instead of weird looking curly braces. So I don't know if you've seen, maybe in movies or you've seen pictures of people programming, you'll see a lot of weird symbols, especially curly braces, right? And those are pretty prevalent in programming languages such as C++, for example. But in Python, when the designers were making Python, they decided to make it readable and just easy to write by using indentation to separate the code into different statements and loops instead of using those weird curly brackets. And that's why it's such a popular programming language for beginners to learn with. And Python also comes with a comprehensive standard library of built-in functions. And once again, that makes it so popular for beginners to use because it just includes so many useful functions right out of the box. And Python is also popular with applications such as AI and machine learning. Once again, because everything is there's so much baked in, and there's an extensive library ecosystem. Next, we have to look at data types because Python needs to categorize data into different types so it knows what to do with it. And this is common with all programming languages. And in Python specifically, we have numbers, which are separated into integers, floats, floating points, and complex numbers. And then we have bools, which are variables that can only have two states. It can only have true or false, or on or off, or engaged and disengaged. And then we have sets, and then we have dictionaries, and we have sequence. And within here, we have probably one of the more important ones, which is string. And string stores words, numbers, addresses, telephone numbers, sentences, and then we have list and tuple. And the reason why data types are important in computer programming is because we have to let the computer know what we mean, right? For example, the number 2 can be read as an integer, or it can be read as a string. For example, if we're making a calculator, we want the number 2 to be seen by Python as an integer, right? Because if it's a string, then it sees it as a word or a sentence, and you can't add 2 sentences together, right? You have to add 2 integers together. And we're going to look more in depth to these data types right now, with the integer being the first one. So the integer data type is a whole number that can be negative, 0, or positive. And this isn't so different from what you've learned in math class, right? This is probably the most familiar one. So for example, negative 256 is an integer, the number 0 is an integer, and the number 5 is an integer. So nothing too abstract there. Let's move on to the float. So the float, which is more formally called the floating point, is similar to an integer, but it just has a decimal. So if you want to have more precision in representing your numbers, you can use a float, right? For example, the number negative 132.5667, the number 0.0014, and the number 5.1409 are all floats because they have a decimal place. And next we have string. And a string is, as I mentioned just a few minutes ago, a sequence of characters such as letters and numbers. And you can represent words and sentences as strings. For example, someone's phone number can be a string. Someone's address can be a string. If you want to write a story, you'll store it as a string because they're sentences, right? So for example, hello world is a string, 123 Sesame Street is a string, and she sells seashells by the seashore is also a string. Okay, so let's do our first activity. We're going to make a Python calculator, a simple calculator that we can use to add 2 numbers together. And we're going to use Code Sculptor to do it. So if it's convenient for all of you guys participating, you can pull up Code Sculptor. That's at this URL here. You can pull up Code Sculptor and you can follow with me while I make our program. But if you don't, no worries. You can just watch. So let me switch here. 1 second. Right here. Okay, so if you go to this URL here, py3.codesculptor.org, you're going to be met with this interface. And what this is, it's an online Python programming environment. So you're going to be met with this here. It's just an example, but we're not going to be looking at that today, so you can delete that. And we are going to make a calculator that can add 2 numbers together. So first, well, 1 second here. First, let's print a message. Let's print a welcome message for the user. When you run this program, the user needs to know what the program is, right? So we're going to use something called the print function. So I'm going to type print. And then in the parameter of the print function, I'm going to type a welcome message for the user. So I'm going to type something like, welcome to my Python calculator. Okay, and then maybe type some simple instructions. Enter 2 numbers that you want to add together. Okay. So what we need to do now is we need to make Python accept 2 inputs from the user. And then it takes those 2 inputs and adds it together, and then it prints the sum to the output screen, right? So we need to store 2 numbers in Python. And what do we use to store things in programming? We use variables. Okay, so I'm going to create a variable. I'm just going to call it first number. This is the first number that the user is inputting. First number equals, and it's going to be an input. So I'm going to use the input function of Python. And the input is going to ask the user to type a number. Okay. And then we need a second input from the user for the second number that we're adding, right? So let's say, let's make another variable that's called second number. And this second number is going to be from an input once again. And the input is going to ask type another number. Okay. Okay, so far we have the user input two numbers, the first number and the second number. Right. Now it'd be useful to create a third variable that stores the sum of the two numbers, right? So we can say sum. This is going to be our third variable. And it is going to be the first number plus the second number. Now we're working with numbers here. And sometimes Python will be confused as to whether to represent the number as an integer or a float. So if we want to keep the precision of the numbers that the user types in, I think we should do this. We should do something called typecasting. We should specify that these two numbers are floats. So when it outputs it, it's more precise. And now we're going to output it. So we're going to type print, and then we're going to type the sum is, we're going to print a string. This is a string saying this what the sum is, and then right after the string, we're going to type the sum itself. And when I type sum here, I'm calling this variable here, which is the first number plus the second number, right? Okay, so I think that's good. I think that's good enough for a simple calculator. So let's run it, this green button here. It's going to say on the right side here, welcome to my Python calculator. Enter two numbers that you want to add together. So for my first number, I'm going to type 1. For my second number, I'm going to type 2. And then there we go. The sum is 3.0. And the reason why it says 0.0 here is because I wanted it to be a float. I wanted it to be a little bit more precise. Okay, but we should, you know what? We should test it. We should test the precision. So let's put 1.55 plus, I don't know, 6.25. And there we go. We have the sum is 7.8. So so there we have it. We have our simple calculator using Python, and we wrote it in just, you know, just a few lines. Now, if you wanted, you don't have to make it just sum two numbers, right? You can make it multiply two numbers, right? So let me try that. So product, I'm going to change this to the product. I'm going to change this plus to a multiply symbol. Change this. So now I change this symbol from a plus symbol to a multiply symbol. And let's see if that works. So what's 2 times 5? 2 times 5 is 10. So let's put a 2 there. Let's put a 5 there. Hopefully that works. There we go. The product is 10. So yeah, there we go. You have your basic template for making a calculator. And if you look at this, you can expand it in a lot of ways. You can add more numbers. You can add a third number, a fourth number. You can change this symbol to be minus or divide as well. And you can even put if statements. You can say if the user chooses plus, then it'll add the two numbers. You can say else if the user chooses divide, it'll divide the two numbers, etc., etc. But because this is our first demonstration, I just wanted to show you that Python what Python is capable in with just a few lines of code. All right, so that was our calculator. Let's go back to the slides. Okay, so let's introduce a few more data types. We have the Boolean, or just the bool, and this data type is used for representing true and false. It's actually used for representing two states, but oftentimes it's useful as a human to think of these two states as true and false, or on and off, or 1 or 0, just, you know, on and off or true and false. And it's useful for making decisions because sometimes you want Python to check if something is on or off or true or false, and you would use a bool data type for that. And lastly, let's look at functions. So when you're writing code, it's often handy to organize your code into functions because they help modularize your program so it's easier to edit and understand. So for example, you want your robot to, you're writing a piece of code to make your robot turn left or right depending on the situation. Maybe when it hits a wall, it turns left, right? Or it turns right. And you can write it directly in there. You can say if you know your robot sees a wall, then it turns left or right, right? But you can also write it into a function. You can write turn left as a function. And right here, this wording, or this syntax as it's called, is Python syntax. Okay, so you would write def to define a function, and this is the name of your function here. And then indented here is the actual contents of your function. So you can say, well, I'm going to make a turn left function, and the contents of this turn left function, well, it's going to be code that makes your robot turn left, obviously, right? And you can make a turn right function, and obviously this function is going to make your robot turn right. And these are just comments here. This hashtag symbol, or this number symbol, represents a comment. So it's not actual code. It's just a comment to say that you would make your robot turn left inside this function. And we're going to look at how we can modularize your program just in a bit. So now let's do an activity where we look at how your block code looks like in text, because earlier, a few weeks ago, you guys started writing your VEX Code VR code to make your robot navigate the maze, right? And you guys probably wrote it in blocks, but now I want to show you guys how your blocks is converted to text and read by the Python interpreter when you run it. Okay, so let's go to VEX Code VR. Let's get rid of this. And I'm going to use the grid map for this demonstration. And you're welcome to follow along if you want, or if you just want to watch, that's fine as well. Right. So when you start a project, you're met with this blank canvas. So let's write a program. Let's write a program that makes your robot trace the perimeter of the playground. So this, let me open up the playground. So this is what the playground looks like. It's the grid map. Let's just write a program that makes the robot go in a square on the perimeter. So it goes up, and then it goes here, and then it goes here, and then it goes here, and it loops around forever. Okay. It's a rather simple program. So first let's make the robot go pretty fast. Let's go set drive velocity to 100, and then turn velocity to 100. And then we want the robot to trace the perimeter of this playground forever. So right off the bat, I'm thinking we need a forever loop. And then inside this loop, we want it so that when the robot is about to hit a wall, it turns right. Okay, so we'll need drive forward first. So the robot drives forward. And then we need it to turn right when it hits a wall, right? And there's so many ways of doing this, but I'm gonna do it this way. I'm gonna do wait until the front eye sees a wall. Front eye is near object, okay? And then, so once it reaches this step where the front eye is near an object, which is the wall, I'm gonna want it to turn right by 90 degrees. And that's it. Let's look through and see if it'll work out. So it drives forward, and then it waits until it's near an object. And then when it is near an object, it turns right. And then it goes back to the top of this loop here, because this is a forever loop. So then it drives forward again, and when it's near an object, it turns again. So it never crashes into the wall, it just always turns right. So let's run it and see what happens. And what do you know? It works. The robot always checks for the wall, and then when the wall is near, it turns right. So there we go. We have a robot that traces the perimeter of this maze. Right. Okay, so this is what your block code looks like. Now let's take a look at what this exact code will look like in text in Python, because in VexCode VR there's also a Python. You can also program it in Python, right? So actually, if you click this button here, these two angle brackets, you will see Code Viewer, and you will see what the Python interpreter actually reads. So when you create this block code, it actually converts it to this, and then the Python interpreter actually reads this. Okay, so I'm going to copy this. This is the program that is generated, and then I'm going to new text project. And I'm going to replace this template with the same code that we just wrote, except in text form. So, so because it's automated and computerized, it has stuff like my variable equals 0, and then we have a variable here. We don't really need that. We can just delete it. And you can see right here, Python is or VexCode VR has modularized it. It has a function, the when started function. So you can kind of understand, when you start the program, it'll do all of this, right? It's not really necessary because we only have like one function, but it's good programming practice. So let's first run this and see if it actually works. And what do you know? It actually works. So this is the text version of the block code that we just created, right? Okay. Now I'm going to modularize this code. Okay, so I'm going to make it more, I'm going to make it scalable and modularized. So when someone else looks at my code, or if I submit it to like someone else to review, they can understand what's going on better. So I'm going to create functions. So I'm going to create a new function called, I'm going to create a new function for these two lines here for setting the velocity. So I'm going to say this function is for setting the speed of the robot. Okay, and so when you're writing a function, you put this colon here, and then when you press enter, it'll automatically indent it. And I'm going to just cut and paste. I'm going to cut these two lines here. I'm going to paste it within this function here. So we have the set speed function. And what else can we do to break it up into functions? We can look here. I'm thinking it's logical to just move this whole block into a function. What will I call it? I'm just going to call it follow perimeter. Okay, so I'm going to create a new function. I'm going to call it follow perimeter. And then I'm just going to copy this part or cut this part and paste it right here. Okay. And now I need to replace what I just removed, right? I just removed this from the when started function, and I just removed this block from the when started function. You know, whatever I take out, I have to replace, right? So I'm going to replace it now with the function, with these functions that I just wrote. So I'm going to put that there, set speed, and I'm going to put follow perimeter right there. Okay. And now it should work. Hopefully. Let me see. Yeah, this should work. So this VR thread here, it's specific to VexCode VR. It just lets VexCode VR know that the when started function is the main function. And that this function will call other functions that are down here. So I'm going to reset it now, and I'm going to run it. And it works. Robot seems to be doing what it's supposed to do. Nice. Yeah, so really what I did is I just took out this block and I replaced it with this. And I just took out this block and I replaced it with this. So this is why functions are handy, right? Because when you want to change something, for example, you're testing it and you say, this is too fast, I want to change it. Then you can go to the set speed function and change it to, you know, like 50% here and 50% here. And it'll affect anywhere else that you have this function. It's not so useful in our program here because we're only using this function once, but say in a big program where you need to call this function multiple times, if you don't have a function and you just have this here everywhere, like whenever you want to change the value, you have to just scroll through and change 100 to 50 everywhere you want to set the speed, right? Whereas if you have a function called set speed and you change it just once here, every time you call the function, it's going to reflect your changes, right? So you just have to change it once. So that's why functions are so useful in programming. Okay. With that said, I believe that is the end of our workshop today. So yeah, so thanks for coming, guys. Hopefully you learned a little bit about text-based programming, and you learned a little bit about you know, high-level source code and then assembly code and machine language. And if you have any questions, your VexCode VR program files are due soon. So if you have any questions about that, I encourage you to ask us here, and then we'll answer them for you.